The bridge that built itself. Self-assembling tech. Imagine a bridge that builds itself. No cranes, no workers, no giant machines. It might sound like science fiction, but self-assembling technology is turning this dream into reality. Around the world, scientists and engineers are designing structures that can shape and assemble themselves using smart materials, robotics, and nature-inspired engineering. One of the most amazing examples? A bridge that can form all by itself. Let's take a journey into how this is possible. Nature has always been the world's best engineer. From the way spider webs form to how plants grow toward sunlight, self-assembly happens everywhere in the natural world. Inspired by these ideas, engineers have created systems that mimic nature's tricks. These include foldable materials, robotic modules that connect like puzzle pieces, and even structures that float into place using magnets or water pressure. The idea of a self-assembling bridge begins with smart materials. These materials are special. They can change shape when exposed to heat, light, water, or electricity. Think of a flat sheet that curls into a cylinder when warmed up, or a strip of metal that bends into a loop when an electric current passes through it. Scientists use these materials to create pieces of a bridge that can wake up and take form on their own. One popular method uses what's called 4D printing. You may have heard of 3D printing, which creates objects layer by layer. But 4D printing adds time as a dimension. The printed object is designed to change its shape after it's made, meaning it can fold, twist, or expand over time in response to its environment. Imagine shipping flat sheets to a remote area, dropping them on the ground, and then watching them turn into a bridge structure when the sun hits them. That's the power of 4D printing. In one real-world experiment, a team at MIT designed small, foldable structures that could fit inside a backpack and unfold into a bridge using only gravity and tension. Another project in the Netherlands built a self-deploying bridge using robotics and hinges. As the components rolled out of a container, they locked into place like a giant jigsaw puzzle. These self-assembling bridges can be a game-changer in emergencies and remote locations. Think about earthquake zones or flood-hit areas where normal infrastructure is destroyed. Getting heavy machinery into these places is often impossible. But what if a bridge could be dropped in by helicopter and then build itself in a few hours? That could save lives. Even in space, this technology is gaining attention. NASA is exploring self-assembling systems that can build habitats or walkways on the Moon or Mars. Sending heavy equipment into space is expensive and difficult. But sending flat, light, and self-assembling materials? That's a smart solution. Of course, there are challenges. Self-assembling systems must be perfectly designed. They need to know exactly how to fold and lock into place. A small error in programming or material weakness could lead to failure. And making materials strong enough to hold weight while still being flexible takes a lot of testing and research. Still, the future looks exciting. Imagine hiking in the mountains and coming across a newly deployed self-built bridge. Or picture cities using self-assembling platforms during floods to help people cross safely. As the technology improves, we might see more bridges, shelters, towers, and even hospitals that build themselves, faster, cheaper, and smarter. Self-assembling bridges are not just an engineering marvel, they're a lesson in possibility. They show how combining imagination with technology can create real-life magic. Just like seeds that know how to grow into trees, these materials know how to become something greater. In the future, construction might not always require people holding hammers. It could simply start with the push of a button and a bridge that builds itself. Like and subscribe.